Hi everyone, thanks for joining us for Getting Started with GitOps. My name is Jesse Butler. I am a developer advocate at AWS. I focus on Amazon EKS and Kubernetes, and I'm really excited to talk about this topic. If you Google this topic, I think you'll see a lot of people are excited to talk about it. But I want to actually focus in the session on getting started. I think I talk to a lot of people and they're just not quite sure where to get started, or they look at sort of a simple hello world thing and then they don't quite know even what questions to ask next, let alone how to answer them. So in this session, that's what I want to do. It's a 300 level session, but it's not the kind where I'm going to point you a repo and there's a bunch of YAML to cut and paste. It's really not that kind of topic. We really want to talk about the concepts and what they mean, and how to plan for adoption. GitOps is really something that you need to do in a team over time to see if it works for you. So if that sounds good, let's get started. So just a quick agenda to set the context. So first, of course, we're going to start with an intro to GitOps. And then we're going to talk about planning for GitOps adoption, which really we're going to go through those principles, but really talk about what the expectations are. And this is where a lot of people aren't quite sure how to get started. Sure, everything in declarative configuration. What does that mean, right? So we're going to talk about that a bit. And then we will look at Flux, which is an open source implementation, sort of a reference implementation of GitOps. And I think it's a really good way to get started. So we'll look at that in Kubernetes using Git and GitHub. I think it's a really good set of tools to just get started. And then we'll talk about adoption and what sort of your next steps or what your first steps would be. So yeah, let's get into it. So these are the four principles. So if you Google and you look at a blog, this is what you'll see. These four things will come up, and that's because GitOps really is a set of principles. It's not a piece of software you buy. It's not a you don't buy a GitOps, just like you don't buy a DevOps. It is a set of principles for operating and managing software systems. So let's go through these quickly, and then we'll dig into them a little more. So the entire system is described declaratively. That means you have declarative configuration not only for your workloads, but for your clusters, add-on software, infrastructure. Everything is described declaratively. Then that declarative configuration is in Git. It is versioned. Approved changes, which are defined there, can be automatically applied to the system. And software agents within the system ensure correctness of those deployments and changes. So that's it effectively. There's no implementation spec. Like beyond this set of principles, that's GitOps, right? So this really extends best practices of things that we've been doing for a while. The real central point here, the linchpin to GitOps, is this declarative configuration and the reconciliation in the system. So Git and Kubernetes and Flux itself are not requirements, but as a reference implementation, it's a really good system to get started with because GitOps really revolves around convergence to the desired state. So this is a different way to look at automation. It's sort of a different way to, it changes the context a little, and it makes the main tool and the workflows Git and say, your pull requests and those typical development workflows. So probably the best way to look at this to get started is to just look at a system. This is a fairly contrived demo and just a little test environment, but I want to just jump into a terminal so you can get an idea. On the main branch, this is the commit that I'm currently synced to. And in this window, we'll start just a little debug pod in the namespace with a simple app. And we'll just curl out the service that's there so we get an idea what it's doing. Okay, so now let's go into the this is the repo that is synced to that cluster, and so we're organized by clusters in the configuration under the cluster name, and then the namespace, and then we can actually get into the YAML, and we're just going to make a change. So the service could be fancier. And now it is. So we have a diff. So let's go ahead and commit it. and push it. It's going to push it to my GitHub repo. And now the sync happens over the course of a minute or so. We see the last commit was AA4D, which is the applied revision we see down in the bottom right. And there it is, it's synced. And now we see we're super fancy. So no kubectl apply. We're actually only in the cluster just to watch it, actually, just for the purposes of a demo. Okay, so that gives us a good idea of sort of what we're dealing with. I mean, it was pretty simple, but it really does give an idea, right? We didn't kubectl apply anything. We actually pushed a change to Git, and the system took care of itself. Now, yes, that's automation, but we'll talk about some of the specifics and why this system is so compelling in a bit. But first, let's talk about why you'd even want to go down this road. Why are you looking at adopting GitOps? So there's a couple of fundamental things here, plus the rest is just sort of this advent of automation and kind of just good DevOps practices. So the pipelines are running from within the system. So that right there is a big change, right? You're typically giving almost godlike permissions to external CD systems. These pipelines are built in the cluster. They run from within the cluster. So for example, your keys to your private GitHub repos are in your cluster, and they can, be held secret. So that in and of itself is actually pretty great. You have this sort of in-scope authorization model. The system itself is simple and fairly consistent. I mean, it's actually very consistent, but it's as far as human readability, it can be a little difficult. But it's fairly consistent to understand what's going on. It's easy to reason about the changes, and what you have is basically a workflow that can scale from just a simple patch to an entire fleet provisioning. Really, the system scales really well, and for the humans involved, it's a consistent experience. So your access to production environments are inherently gated. That's an inherently gated aspect of the system, and it's controlled. And we'll talk about that in a bit when we talk about repository organization. But effectively, everything's coming through Git, so you can control sort of on a team by team or even an individual by individual basis who has access to which repos and who can merge PRs. The desired state for any point in time is observable and immutable. That just means it's all in Git, right? And so with some good tooling, you can actually sort of get an idea of the intended state, the desired state of your system at any point in time, which is super powerful. But also in the present time, the difference between the desired and actual state's monitored and it's known. And, it could be that you're looking at kubectl logs, or it could be that you're just looking at your Slack channel, right? I mean, even Flux out of the box is effectively ready to send your team notifications when things drift. So this is a pretty powerful system out of the box. And it really comes down to knowing that, your CD system, if you're in Jenkins or whatever, it doesn't necessarily know what's going on in your cluster, right? It just knows that it had a job that succeeded at some point in the past, right? And with a system like Flux or another, GitOps system in your cluster, it's constantly monitoring the state. That's a pretty powerful thing. Basically all of this adds up to reduced operational overhead and therefore increased velocity, right? So more time focusing on code and coding workflows and less time context switching and sort of bouncing from here and there, trying to chase down problems. That said, GitOps is not magic, right? It doesn't fix bad practices. It just promotes good ones. And when you're working with the software, it's hands-free, but it's not for free. Like you have to be aware of what's happening. Basically you're looking at adopting an opinionated implementation of continuous delivery. And it has to become part of the practice of DevOps. That brings you to planning, and choices around this stuff. Like I said, GitOps is really a short list of high impact principles. There's a lot of things to still decide, from repository layout and how you're going to respond to drift. And there's a lot of things that are left for you to decide as a team. So for the purposes of this talk, we're going to walk through some of those questions with opinionated particulars in mind. Again, using Git, Kubernetes, and Flux. But just keep in mind that a lot of these are implementation choices. So let's look at some of the questions that we have to ask around planning for GitOps. And one thing is, we're just going to walk through these principles. We're going to walk through them one step at a time. Before we do that, I just want to point out that within the CNCF, there is a GitOps working group that's spun up, just starting to work on this community-driven understanding of what GitOps is. So I just wanted to call that out because it's really exciting work. It's just spun up in the CNCF sandbox, so keep an eye on that. But again, these are the principles that we are working with. So let's go through them one at a time, starting with the beginning. So the entire system is described declaratively. So this is really the evolution of deployment automation. In this case, we're talking about everything, right? So infrastructure, cluster configuration, add-ons, the whole works needs to be declaratively described. I can't really stress this enough. I think a lot of people think, well, I'm just going to spin up my clusters by hand and then I'll sort of do the other part. And that's okay to get started, but literally just to get started. To really get the power of GitOps and really the reason for doing it, it's got to include clusters and infrastructure as well. And we'll get to some of the reasons for that, but just know that this really is part of the expectation. And I'm calling out things here that integrate very natively with Kubernetes. Again, not a requirement, but you can look at things like Cluster API. Crossplane is a really awesome open source project that's also CNCF. So both of these are options for spinning up clusters, in Kubernetes YAML. Like you put that into a control cluster and it will spin up clusters for you. So that actually fits this model really well. And we have the AWS controllers for Kubernetes, ACK. My slide says Amazon, not sure why. So AWS controllers for Kubernetes. This is a thing where you have a set of controllers for AWS services. So you'll be able to provision things within AWS from within Kubernetes, just using YAML and CRDs. So that's really cool. So you can, have things like RDS database instances and S3 buckets and SNS queues. So that's pretty cool. And then you have good old Kubernetes YAML to define your workloads, and these other things too. So really this is very doable, but it can be a lot of work, especially if you're not doing it yet. So we just wanted to call that out. I think that's probably the first prerequisite of really getting into this. I think this one's probably more likely that everyone's doing, but it is important to use version control. So basically with all of this declarative configuration for your workloads, your clusters, and your infrastructure, you've got to put it into version control. Now it doesn't have to be Git, but Mercurial ops doesn't sound as good. Git is not a requirement. In this case, we're talking about using Git just because it's easy to get started with. But know that it's not necessarily the case that is a requirement. What really is required is that everything is versioned, right? We have immutable artifacts for our declarative configuration, because then we get to the next step of automatically applying changes, and we need to know what we're applying. We need a source of truth, right? So from Git, we can have these approved changes be applied automatically from within the system. So this is the marriage of declarative configuration and reconciliation in the cluster. The cluster is constantly driving toward it's driving the actual state to be converged with the desired state. So Kubernetes is not a requirement either, nor is Flux, but the design and the extensibility work so well, and Flux is actually an example of this. So Kubernetes is designed in a way that's extensible with controllers and CRDs, and it makes this work really well with Flux. So it's a really good system to get started with. And that brings us to what runs in the cluster. So the software agents that ensure correctness. So this would be, in our case, Flux, which we're going to look at. But there are other options with Argo and other things. You could even roll your own. But obviously getting started, we'll just look at a reference implementation. But the idea here is that agents within the system are constantly monitoring for configuration drift, which is basically just defined as differences between the desired state that's in Git and the actual state running in the cluster. So these agents are constantly monitoring that. And, if you actually apply a change directly to the cluster, it'll get reverted because the system is constantly converging to the desired state. So this is a form and sort of a context shift for the automation, right? So we're shifting from, sort of scripts that run or cron jobs to an agent that runs that constantly monitors for change. And no matter which way it changes away from the desired state, it's going to be changed to the desired state. So if you have somebody log into the cluster and make a change, it's going to get reverted. Or if something breaks and needs to be repaired, it's going to get, kind of reapplied. So basically the system is constantly taking care of itself. And so in practice, this is what we end up with. Merged pull requests become running code, and version controlled reverts will trigger a rollback. It's that simple. And so we stop SSHing to nodes. We don't need bastions. We're not logging into Jenkins to debug something. We're not sort of context switching all the time. We stay in the Git workflow, right? We're writing code. We're making configuration changes. We're pushing. People are reviewing PRs, they're getting merged. And that's the workflow that drives change through the whole system. So Flux is an open source GitOps reference implementation. So GitOps relies on tooling, right? I mean, basically all modern DevOps relies on trustworthy automation. But GitOps literally says it only has 4 principles, and one of them is there are software agents, right? So the principles explicitly require that those exist. So Weaveworks really pioneered this space. They first coined the term, in 2017. They have been working on this family of controllers called Flux pretty much the whole time. So Flux is in the CNCF. They've donated it, and it is currently it's been in the sandbox for a while. It's just recently been promoted to incubating status, which is fantastic. So we'll look at Flux. It implements the in-cluster software agents for GitOps. So it itself is implemented as a set of Kubernetes extensions, which control how Git repos and other configuration sources are synced. So that's how they're applied to the cluster. We call that syncing. So Flux can sync from an arbitrary number of source repositories, and the source repositories can be Git or Helm or S3 compatible buckets. And it supports multi-tenancy and fleet management from one control cluster. It's completely customizable. As I said, it's open source, it's extensible, it's a really good system. And Flux v2 is the new version. Well, not new, but this is a full redesign based on lessons learned running the first version. So the team is great, and they've been sort of working with it, and they themselves have been frustrated by aspects of v1, so they just decided to rewrite it. And it's built using this GitOps toolkit, which is a set of Kubernetes controllers and CRDs. So it's basically everything you need to get started. So we're going to go through it. We're going to look at the different pieces, and I'm going to show a little bit of it in a sort of a demo environment. But I'm not going to get too deep, just because I really do want to get through some of this other conceptual stuff so that you can hit the ground running. But also, the demo stuff that I do is actually going to be from their site. So that's in the CNCF. You can see this toolkit.fluxcd.io. If you go there, you can actually pick it up where we left off. Anyhow, let's look at Flux. So this is basically sort of top down. Flux has these 4 controllers, a set of CRDs for each one, and then a CLI. All right, so there's a source controller, which derives the sources from outside the cluster, pulls them in. There's a Kustomize controller, which really does most of the workhorse around, sort of monitoring deployments, doing deployments, making sure things are running as they should be. There's a Helm controller for managing Helm releases. And then there's a notification controller for inbound and outbound event management. So we're going to talk about each one of these, and then we're going to talk about the utility. So the source controller, its job is to provide this common interface for artifacts acquisition from outside the cluster. So you can see that it supports Git and Helm and S3 compatible buckets. So it validates and authenticates sources. It detects changes, and it fetches those changes and pulls them into the cluster, and it packages them and makes them available. And then it notifies that they're a new version. So that's its job. So you can see this supports, Git, which is GitHub, GitLab, Helm, and Helm charts in Git, and Helm charts in S3 buckets and then S3 buckets. So it's basically, it's pretty flexible right out of the box. And it comes with this, set of CRDs. So for example, here's a Git repository that we're configured, and it's fairly straightforward, as you can see. So you provide an interval for monitoring and the branch to use, and then the URL. And when you configure it, you actually have your Git repository or your Git user and your token in play. And so those come in as secrets, and they actually end up in the cluster. So then you have the Kustomize controller. So this is the thing that actually runs the pipelines within the cluster, right? So this is the workhorse of actually making the changes in the cluster. So it reconciles a cluster state constantly. This is configurable, but it's basically constantly looking at what's happening in the cluster, and it compares it to the sources. And it generates and validates manifests with Kustomize. So this is where you can have templates and paths, and you combine that with workloads and specifications, and Kustomize will pull them together and actually ensure that they're running. And it's constantly assessing the health of the deployed workloads, and it just runs these pipelines all the time and then reports state changes. So again, getting out notifications. So here we can see a customization that uses a source. So down at the bottom, we see the source ref of a Git repository, which pod info, which is what we had defined before. And this is the customization. So it shows you that's, /customize, and it has prune set up. So it'll actually remove, as it goes through reconciliation. And so, yeah, this is fairly straightforward, but you can imagine how powerful this is, right? If you think of, layers of templates, and you have various environments, for any given resolution here where we're pulling in the right templates, the right environment, it can be really flexible. So here we have the Helm controller. So this is really Helm releases. So you can have a Helm chart in source, but here we have a Helm release. So this monitors Helm release objects that you define, which we'll look at in a sec, and it creates Helm chart objects. That monitors the sources and fetches changes, and then it can actually perform automated Helm operations like installs and upgrades. And then in the case that a Helm operation fails, you have configuration options for remediation, like retries, rollbacks, quit, whatever. And here, pulling that together in a CRD here with the Helm release, you can see there's a source ref again, just like our Git repository before. This one's a Helm repository. And so you have a Helm repository for this app called pod info. You specify the version. That's pretty much it. That's pretty cool. So you pass that in, and it, the controller takes care of what you need, which is really great. So one of the central players to the system, and as far as it working, is the notification controller. So that handles outbound events. So you can have notifications to, say, Slack or Discord, but also inbound events. So and it also notifies other controllers of source changes, right? So it's constantly chattering, within the system, inbound and outbound, but also can do inbound and outbound from the system, from the system context. So out. In from Git, Harbor, GitLab, Jenkins, and then outbound to things like Slack, Discord. And you can actually customize handlers for this too. It's really cool. So just for something that's built in, if you wanted to, say, set up really simple notifications to Slack. So you'd set up the secret with this one-liner, and then you can reference the secret in a provider CRD for notifications. So here we have a Slack provider with that URL. And then you would define an alert, and the alert actually references that Slack provider. And you say, well, for the event sources. So the events are anything in the Git repository, anything in customization, go ahead and alert with that Slack, and then you get Slack notifications. I mean, pretty straightforward, but super powerful. And it's nice that it's built in and also extensible. So, and we're just really just scratching the surface here. I am just blazing through this. I really want to make sure that we do understand the components that are running here. So anyway, for our purposes, let's just look a little more specifically at Flux itself, the command line utility, and bootstrapping an environment, because that is something you're going to want to do basically right when you get started. So Flux has this unified command line, and it's you can use it to create and delete and administer parts of the Flux system, view various cluster resources, and it also has an integrated bootstrap command. So bootstrapping is installing all of the Flux components that you need in a GitOps way. So it actually will go into the cluster that you identify and configure it with all of the components that are needed to run the system, right? So let's go ahead and just jump into that demo environment again, and we'll take a look at doing this. We're going to use Flux to bootstrap an environment, which includes actually creating a GitHub private repo in my GitHub account. Okay, so back in the terminal here. So yeah, we're going to actually create a private repo in the GitHub account. So we just have to export for Flux to pick up. Actually, not even the user, just the token. And Flux has a pre-flight check. So I've switched to another cluster that doesn't have Flux installed at all. So I was just going to double check that everything's okay. It's a little down rev. That's fine. So everything's ready to go. So this one-shot command will actually go ahead and bootstrap Flux in this cluster. And because I've given the owner the credentials for GitHub, I've indicated a personal account and a private repo. This will actually go ahead and provision all that for us. And we'll install the controllers, install the CRDs, everything that we need from scratch, basically, to get started. And it's verifying. So I'm just going to bop over here and expect, what do we call it? Bootstrap demo, I think, right? Yeah, we actually have a brand new repository, which, I knew it wasn't lying. So now what it's actually doing is using GitOps to deploy the Flux system, right? Which is pretty cool. So here we have this boilerplate that it put in place. So the components, a sync, a customization for Flux itself. But now we actually have a repo where we can add things to this just with our Git workflow. It's already done. So what did that take? Like a minute. So what I'll actually do is just add a pre-baked little demo app that is from Stefan at Weave. Actually, this is a nice little app, and it is the one that he uses in those docs. So again, I'll just use it so you can kind of pick up where I left off. Oh, right. I forgot. I have to clone it locally. So let's grab a copy of here. Let me clean up my terminal. So grab a copy of our repo, CD into it. Actually, I like to put everything in here. All right, cool. So now we're here. So so Flux will create YAML for us, which is pretty rad. There's a lot of different ways to use this, but that just with some command lines. So we're given the URL for the repo, which branch to pull from, the interval to check, and then an output, and we have some YAML. So we'll go ahead and this is a source, right? So the Git repository, this is a source. So we'll put that in the cluster, and Flux will, the source controller will get to work and at its regular interval go and pick it up and make it available for use in the cluster. Oh boy. All right, doing good. All right, so now we just committed, so we'll push. All right, cool. So that's now there. Now that's a source, right? So we also now need a customization to create the deployment. So we'll go ahead and create that as well in our repo. And that is another, CLI. Just you can create commands create YAML like this is really handy. So now we have a customization. We'll actually deploy the app. So before we commit this, I'm just going to do, another watch on the Flux Git customizations, and we can actually watch the sync. So we'll commit this one. Oh, okay. And now we'll push that too. So this is the customization. It'll actually result in when this syncs, we'll actually get things deployed. I think that's just in the default namespace. So that's actually already there. That was pretty quick. So so you can see how quickly that goes. So, and this is, again, this is the current state of our repo. Now I know this is a super simple demo, but you get the idea, right? The workflow here, 1 minute to bootstrap, add a couple of things in, and you're up and running. And now, of course, any changes that I make in that repo will be automatically applied to the system. Okay, cool. So another kind of quick and basic demo. We're really just scratching the surface, but I guess that's good because we can see how simple it is to get started. And it really is. So I'm intentionally using some of those demos, like I said, from the Flux project itself, so you can easily pick it up. There's some other stuff on there, plus they have other GitHub repos with other tutorials. We're going to be working on some more content out of our team. So if you have any ideas of what you would like for us to dig into, let us know. Reach out anytime. So let's move on to adoption and practice, because I think this is sort of the meat of what I wanted to talk about, really. You know what GitOps is, you know how Flux works as an option for building an environment. How do you use it? How do you get started, right? So that's where I want to go to next. And to frame that, I want to talk about what the goals are. So we kind of want this sort of old school enterprise IT stability, but we need cloud native velocity and flexibility, right? We want like both of those things. The recoverability, transparency, and predictability of the system are all really important. And effectively, you want to get to this point where you're working on code, you're staying in these development workflows, you have less context switching, but you also trust the system more, and you know that it's doing what it's supposed to be doing. So how do you get there? So I think the first thing to think about is getting organized with your repository. So as you've seen in a couple of demos here, everything runs through Git, right? It's GitOps, which means your repositories are pretty critical. Now, if most of your work is coming through repository workflows, typically, depending on where you're working, typically your permissions are repository wide. So I guess that gives us the first foothold. We can separate authorization scopes into their own repositories. So if you think about it, creating clusters and infrastructure and deploying workloads to them, those are not within the same scope usually, typically not even in the same team. So that gives us a first starting point. We can separate infrastructure repos and workload repos from each other. And once we get here, we can also think about separating production and non-production workloads into their own repos, because typically you don't have the same scope of rights. You don't have the same authorization to deploy to prod if you can deploy to dev, right? Or dev test or non-prod. So we can also separate production and non-production workloads. And you can see right off the bat, just drawing these sort of pseudo paths, that you have one team that's working on clusters and infrastructure, and they come into the management cluster and they impact everything. Then you have on the right side your workload repos, and you have a production workflow, and you can see clearly that production comes into the management cluster. Production can only deploy to staging and prod in this example. And then your dev test has a lighter color coming out of it, and it's only deploying to the test cluster. So you can see inherently that we've already set up sort of the granular permissions and the right scopes to get started. And we can get a little more granular from here. So we can also collapse on either side of the prod line and use branches. So we have separated production and non-production, right? So on the left, we have non-prod, we have dev and QA. On the right, we have prod, staging, and prod. I know not everybody considers staging prod, but others do. So I'm just using this as an example. We basically separated prod and non-prod. So if we don't have branches like this, we're going to have 4 repos instead of 2. Now, that might be okay until you start thinking about then, well, what if you're going to have several repos for sources? And the next thing you know, you have like 58 repos that you don't necessarily need. So I think that this makes sense. We don't want everything in one repo, right? We don't want to bring production and non-production together. But if we think about the reason, it's responsibility and authorization, right? Scope of role. Typically the same scope of role or similarly scoped environments are the same people, right? So you have, dev and test and you're sort of doing all of that on one side. And then you have prod, maybe SREs or maybe, systems platform team they own staging and prod. It's the same people on both sides, or at least the same scope of authorization, right? So if you think about it that way, this seems pretty safe. So we've separated prod and non-prod, but we can use branches. So where's the source, right? So that you might have, I don't know, 5 or 6 microservices. You might have 500 or 600, right? So each of those are just going to stay in their application repos like they are right now. And there you're going to have, build environment, maybe your Docker Compose files. You might even have Kubernetes YAML in there. But the thing is that that's where your development workflows are going to come from. And it's going to seed all of your workload repos. But you're not going to actually deploy directly from those anymore. Right? Those are going to come in and they're going to marry with the templates and they're going to get all the customized. Maybe you're going to use Helm charts, whatever it's going to be. And then coming through the filter of the workload repos, then they'll come into the management cluster and they'll be applied to the clusters. And whether that's, test or staging or prod, it doesn't matter. So this is roughly what it looks like. Your application repos stay the same, and then you have your workload repos, which are separated between non-prod and prod, and may have multiple branches on each side of that line, if that makes sense. So you see the power here where, let's just zoom in on one thing, right? So the catalog service, maybe one of the aspects of this has a Helm chart. And the Helm chart has a template and some values. And now those values in the application repo are going to be suitable for maybe standing up a development environment or maybe just running a one-off test. Now, if you come down into the prod branch, you see that there's an apps directory with the catalog service, and there's a Helm release with values. And those values are going to be different. Those values are going to be for production. Now, you can imagine this for a QA test stand, for staging, for prod, for all of your services, for prod and non-prod across all of your clusters. You can do this pattern, and it's incredibly powerful. Now, this isn't new, but the idea that you can bring this into one scope and then have one tool to sort of reconcile everything and drive the automation for it is just super rad, right? So I think that this is a really powerful aspect of this, and it's just one example of how the system works. Now, if all of this is sort of making your eyes cross and you're going to have to watch it later and rewind and then finally grok it, then realize this is super powerful and this is a really easy way to get into this, because we used to do this with like bash scripts and awk and sed running in Jenkins and multiple jobs, and it was not fun. It wasn't fun. So this is really very powerful. This is really cool. So the changes are automated in the system, like we said. That's part of the principles. The approvals aren't, or likely. I mean, they could be, right? And as we'll talk about at the end, that's sort of maybe a goal, right? Compliance and policy automation. But let's just consider approvals aren't, right? Human in the loop automation totally makes sense for some things. I mean, we have CI systems, but we have manually approved PRs, right? So developers can maintain these iterative, high-velocity workflows that they need, while cluster admins can normalize the cadence and the scope of changes across the system. So this is actually exactly what we want. So commits flow between dev and test cycles in their own environments with PR approval workflows, and humans approve things. And then when it's time to promote to prod, you just do the same thing. You have a PR. But instead of a PR between branches, you're now going to PR between repos, right? And with this model, pull requests between branches promote workloads between environments on either side of the prod boundary, right? So you can have a dev and test process happening where you're iterating on a dev build and it's going through test, and you finally get it to the point where it's working, has all the features you want, it's passing all the tests. Now your pull requests going from dev to test and dev to test, they finish, and now you can file a pull request from non-prod into prod staging. And that non-prod crosses that non-prod to prod boundary. So you're going to have different people involved maybe in that pull request. You're going to have a different team actually even with oversight. And it comes into staging, and then it's that workflow, right? Where we're doing some testing, observation, maybe you've got some canaries happening. And then eventually to promote that, it's a branch to branch, right? So you're going to promote from staging to prod with a pull request across the branches. And it's a different team doing that maybe, or maybe you're still involved as a developer. Either way, that's a decision for your teams to make, but the workflow is actually pretty slick. So I'm probably going to belabor this a little bit, but it's really important that your clusters and your infrastructure are part of this plan, right? So clusters, cloud resources, operational add-ons in the cluster, the configuration, everything needs to be declaratively specified in Git. So as I said before, you can use cluster API, cross-plane, ACK. I know I'm repeating myself, but it's really important that this plays into your plans. Because if you get this in place, a single management cluster can provision the rest of the system. And so if you have 3 clusters, that's fine. It's very nice, it's handy. If you need 500, it's also very nice and handy. It's the same workflow, which is pretty great. So you let the system work it out. So that's the power here. And also, if things start going sideways, you need to do updates. You need to change your operational add-ons. You need to change one config value. You just do it with a pull request, and the system sorts it out, all from one management cluster. And most importantly, once the thing's running, just like with your workloads, your clusters and your infrastructure only change persistently through a change in the desired state, which means you're intentionally changing code and you're filing a PR, right? If your clusters, your infrastructure change without that, then they're going to get reverted, right? There's no persistent change without, a pull request or a git commit. So that said, let's talk about how to organize this. This is different. So branches, like I said before, I think work really well for workloads. That makes sense. Directories seem to work better for clusters. So you might have a bunch of clusters that all share the same templates. And you're typically going to be scoped in the same authorization, right? This is typically owned by maybe a platform team or SREs. So it makes sense that actually you have this one folder of templates for your environment types and then all your clusters, right? And rather than sort of going back and forth between branches for each one of those, you can just kind of copy them, so if you spin up 10 more clusters, you just kind of put them in there. So this tends to make sense. And now you see how easy it is. You marry something. So for example, if you're going to create a test cluster, you marry the cluster config with the dev test or the non-prod configuration. Send that into the management cluster. Flux does its thing. It invokes cluster API maybe, and boom, you got a test cluster. So this is pretty powerful. Regardless of how you organize this, don't repeat yourself. That's the dry. So, ideally changes to the system involve a configuration change in one place. What you want to avoid is having 500 subdirectories with a bunch of YAML files that are 80% the same. Don't go back 20 years, right? Move forward, be dry. So use templates, create modular templates, import templates into other templates, just be very abstract. And people have written whole books on this. So that's not really it's a little out of scope for this talk, but I'm happy to talk about this anytime. But basically anything you can do so that changes are easy to understand. Ideally configuration changes happen in one place in your entire system. And you sort of these well-formed, well-organized changes promote predictable and uniform change throughout the system. Sort of follows itself. So I will say the simplest way to do all this might feel like a monorepo. So I just wanted to call this out. I'm not here to say, don't use vanity tags on your images, don't use monorepos. I'm not that guy, okay? But I will say monorepos can work with GitOps, but not typically at scale. And really it only works if it's a single team that manages both infrastructure and workloads, so your infra, your clusters, your workloads, everything, and both prod and non-prod. Like if that's you, then this can work. It's typically not anybody, but if that's how your team works, you just own everything all the time, then you can use a monorepo. But even then, there's some things to think about. So first of all, your CI system is going to need a lot of work and a lot of customization, a lot of backbending, unless you just want to rebuild the entire world for every push. Right? If you've got a monorepo with like 20 services and 15 clusters, there's a lot of moving parts there. And every time you push, CI system is going to build everything, or it needs a lot of work. It's also highly unlikely everyone should have access to everything, but you do you. I'm not here to tell you you're wrong, but I think takeaway should be have very strong evidence to support a monorepo. Otherwise, just don't go down this path. So one of the underpinnings here is configuration drift. So you just have to think about, so configuration drift is basically it's any time the actual state differs from the desired state, right? So the response is quite configurable. I mean, out of the box, Flux works in a certain way. It will revert those changes, but you can actually be flexible with this. And even there's a new alpha controller for images where you actually can sort of invoke change from within the system. I think the way to start from, sort of from the beginning in adoption is just start with the basics. Just start with how the system works and iterate from there. But, I think there's a lot of flexibility in the system. One more big aspect here is around observability. I mean, observability is always critical when you're working with ephemeral compute and workloads, especially. We've done a whole lot of work in observability for containers over the last, 8 years or whatever. Ephemeral infrastructure requires as much, planning. You have to actually have an idea of what you're looking at, what you're monitoring for. Dashboards for everything, determine what those things are for your team, what's important to you. There's some nice some nice default dashboards that come with Flux, and they're customizable, of course. And then from there, determine what to do with that data. Alarms, response automation, team chat integrations, whatever you're going to do, just plan it out and know that you can do it. And probably the default stuff is pretty good to start with. Planning for failure, you always have to do that, right? So we're embracing ephemeral infrastructure. This cattle not pets now extends to infrastructure. Just let the named clusters go, let everything burn. It's going to be fine, right? Full system stand up through a PR is absolutely a thing. I've seen it. It is super cool. So this reconciliation and convergence to desired state at scale, like when you have 200 clusters and thousands of services running, it's pretty amazing to just sort of roll the thing out and get a cup of coffee and watch it go. So getting to that, right? We're sort of wrapping up our time together. I want to talk about where your path might lead. So getting started is like here, right? You're on a laptop, you're going to play in a dev cluster. You're working with declarative infrastructure. It's not reconciled. You might just be using something like EKS Cuddle to stand up an EKS cluster. You might even just be creating one, in the console. You're using GitOps for workloads, automated reconciliation, right? You're going to use Flux, pull-based deployments, right? We have all that. Really, the next phase, scaling. This is where you want to start rolling your teams in, start socializing this, and really start getting the planning done. So this is, I think, a good goal for most orgs. You're moving to GitOps for both infrastructure and workloads. This finer granularity on repository organization is what we talked about. I think it's a great place to start so you can see where you're going to scale and what problems you might have. All of, basically everything is reconciled, workloads as well as infrastructure and clusters. Progressive delivery is being used, canaries, blue-greens. You're using templated customizations. This is a great target. Starting here, totally cool. Get a POC together, but move into this phase as quickly as you can. Obviously, depending on how big a team you are, how big an org, this is sort of the final, sort of the holy grail, where you have multi-tenant, multi-cluster roles, you have full compliance across the entire fleet, you have automated policy, auditing, you have, intent-aware infrastructure configuration, so you can know if you're running at edge, if you're running in the cloud, if you're running on premises. I mean, this is the whole thing. This is doable. This is where most people are going to be, but this is doable. So just wrapping up, I think this is a great place to start using Kubernetes, Git, and Flux. Fairly easy to get a POC up and running and move it into a production environment. I really hope that this session has met your expectations and given you some ideas on how to get started and sort of how to plan and how you can actually meaningfully get started with this in your teams. We're going to be working on some more content here, so let us know if you have any ideas on what you'd like to see. You can reach out to me anytime, so that's my email and my Twitter handle. I really appreciate you spending time with me. Hope this was a useful session to you, and I hope to talk to you more in the future about it. All right, thank you very much.